So the next one is the functional group. Okay, what is meant by the functional group? So now in the hydrocarbons, we are having only the carbon and the hydrogen atoms. So using this hydrocarbons, we can use it only for the burning purposes or something. So what we are going to do over here is, so we are going to substitute the, in the place of the hydrogen atom, we are going to introduce the some other non-metals. Say for example, chlorine, oxygen, so bromine, iodine. So we are going to introduce the one other elements. We are going to substitute the other element. So that we call it as a functional group. So when we are introducing the some other element into the hydrocarbon, so their properties are completely changing. So they are having a different kinds of the properties. Their polarity will be changing. The reactivity will be the different physical properties, chemical properties. Everything will be changing by replacing the one hydrogen atom with the other atom. So that we call it as a functional group. So the atom or the group of the atom which decides the property of the carbon compound, that we call it as a functional group. The first one is the halo. Halo means the halogens, so which is present in the group 17 in the periodic table. Chlorine, bromine, fluorine, iodine. So those we call it as a halogens. Okay. So now here, so we know that the methane formula is CH4. So this is the methane. So now here, the one hydrogen atom, we are replaced it with the chlorine atom here. So this we call it as a chloromethane. So how to name this one is the chlorine is present, so it is a chloro. And this is the one carbon atom, right? So this is the methane, chloromethane. So in this one, this is the bromine atom is substituted. So the formula for the ethane is C2H6. So in the place of the one hydrogen, so we have substituted with the bromine. So bromoethane. So there are two carbon atoms present, so we call it as ethane. Suppose in the case of the C3H7I. So this we call it as a iodo. Iodo. There are three carbon atoms are present, so it is a propane family. So propane, iodopropane. Like this we have to name. So what is the use of substituting this functional group over here is CH4 is nothing but the gas. Okay, but in the place of the one hydrogen atom, we are going to introduce the one chlorine atom over here. So chloromethane is nothing but the liquid, and also it is a polar compound. We are using it as a solvent over here. We can able to dissolve more polar molecules over here. But then CH4 is the non-polar molecule. We are just using it only for the burning purposes. It's having a wide number of the uses. So while we are changing the one atom in the particular compound, we are getting a number of the compounds that is having the numerous properties as well as the uses. Next one is the alcohol. So the alcohol is having the functional group OH. So it always ends with the OL. OL means alcohol. So from the name itself, we can able to identify what is the functional group which is present in the particular hydrocarbon. So methanol. So OL. So OL indicates that OH group is present in that. Meth indicates that so there is a only one carbon atom is present. In that carbon atom, we are having the OH group. So the remaining bonds and all we have to satisfy with the hydrogen atoms. Next one is ethanol. Ethanol. So OL indicates that it has a functional group OH and eth. Eth means there are two carbon atoms present. So C2H5OH. So this is the ethanol. Propanol means we have to write with the C3H7OH. So this is a propanol. in the place of the one hydrogen atom, we are going to substitute the OH group that we call it as alcohol. Next one is the aldehydes. So the aldehydes are having a CHO. So in this case, okay, it ends with the AL. So we should not mess up with these two things. OL means alcohol, AL means aldehydes. So in here, the CHO, if the CHO group is present in the compound, that we call it as a aldehyde. Okay, so what is this CHO? So this single bond carbon, double bond with the oxygen atom and single bond with the hydrogen atom. So this we are going to substitute with the hydrocarbons. So methanol. So Al indicates that it contains the CHO. So in this case, meth means only one carbon atom, right? So already it has a one carbon atom. So we should not write one more carbon atom again. So CHO is already has a one carbon atom. So in this carbon atom, it make a double bond with the oxygen and single bond with hydrogen, and one more bond we have to place it with the hydrogen. So this methanol is it's otherwise known as the formaldehyde. Formaldehyde. So the formaldehyde is nothing but it's very good. This one, the preservative in as a biological specimens and all. So HCHO is the formula. Then ethanal. So here also Al. So the Al indicates the aldehyde group. So it indicates that it should contain only the two carbon atoms. So two carbon atoms we have to write it. One carbon atom is containing the CHO. The other carbon atom should be balanced with the three hydrogen atoms. So CH3CHO, we call it as a ethanol. The next functional group is the carboxylic acid. Carboxylic acid is COOH. So this is the complete structural formula for the acid. C is making a double bond with one oxygen and single bond with one oxygen and single bond with hydrogen atom. So oxygen can able to make the two bonds. Carbon is having a four bonds, right? So the two bonds with one oxygen and one bond with one oxygen, and in this case the oxygen is making a single bond with carbon and single bond with hydrogen. So now in this case the oxygen is having a two bonds over here. Okay, now we are going to, so this is end with the oic acid. If there are one carbon atom is present, so methanoic acid. If the two carbon atoms present, ethanoic acid, propanoic acid. So like that we have to add the oic acid after the particular hydrocarbon. So methanoic acid. So methanoic acid indicates that it should contain the COOH. Again, already the acid group contains the C. Myth indicates that only one carbon atom should be present. So already the one carbon atom is present over here. So we should not write one more carbon atom. So we have to balance it with the hydrogen over here. So HCOOH. This we call it as a methanoic acid. So next one is the ethanoic acid. So COOH. So eth means there are the two carbon atoms present. So this COOH is combined with making a bond with other carbon atom. There are two carbon atoms present. So it is a eth. So this carbon atom is balanced with other three hydrogen atoms. So this is the ethanoic acid. Propanoic acid means CH3, CH2, then COOH. So this is propanoic acid because it contains the three carbon atoms. So it's a propane group. So it's a propanoic. Acid indicates that because it contains the COOH group. Okay. Next one is the ketone. Okay. Ketone is also having the C double bond O. See here, there is a basic difference between the aldehyde and the ketone is aldehyde also has a C double bond O. Ketone also has the C double bond O. Now, how to make the difference between the aldehyde and the ketone is aldehyde, one of the bond it has to make with the one hydrogen atom. But the ketone, The C double bond O, both sides it has to make a bond with the carbon atoms only. So that is the difference between the aldehyde and the ketone. So here it is a CHO. Hydrogen should come. If the hydrogen is coming, we call it as a aldehyde. So if the C double bond O is making up with the two different carbon atoms, that we call it as a ketone. So it's N with the ONE. So it cannot able to make, it needs three carbon atom at least, because we cannot substitute with the hydrogen. If we are substituting it with the hydrogen, it becomes an aldehyde. So there is a no meth or eth one. So it's starting from the propanone. So CH3, COCH3. So this carbon atom is making a bond with one carbon atom this side and one carbon atom this side. So this we call it as a propanone. So butanone is, this is the C double bond O. So here it's making a bond with this carbon atom and here it's making a bond with this carbon atom. So this is a butanone. Why we are calling it as a butanone is 1, 2, 3, 4. There are 4 carbon atoms present. So it is a but, and the C double bond O, the functional group is present. It's a one. So it's a butanone.